Hi class, we get to start off a new unit. It's one of my favorites. We get to talk about the mole. So the mole is a very special unit in chemistry. And so before we dive in talking too much about it, I want us to think about, okay, how do we count by weighing? And so we're going to work in using real life examples and apply it to atoms and molecules. So in our case, if we think about if we have a very big number of an item, so like way bigger than anything you could count by your hand, how you figure out how many you have is by dividing the total mass of a sample by the mass of that individual piece. And so the example that I like to talk about is the US Mint, which they are in charge of counting millions and millions of coins. So of course it doesn't make sense for them to do these counts by hand. And so we do the same thing in chemistry. We actually count our atoms or number of molecules by weighing. And so it's just a simple calculation where if you have the mass of entire sample, so your total, and you are going to be dividing that by the average mass of an individual piece. And so what this is going to give you then, in turn, is going to be equal to your number of pieces. And so we're going to do this example thinking about units, all right? And so looking through, it tells us that we know on average that there's about 5.670 grams for every quarter. And let's say at the US Mint, they take a mass, and on that scale, you have 1.1 million and some grams total of quarters. So thinking about this equation that I just introduced, what we have here then is our mass, obviously average mass of individual, and then we also have our total sample mass. And so how we're going to put this into our equation then is we are going to write first our entire sample. So 1,164,890.16 grams. That is how much we have for our total sample, right? And so then we are going to divide this by individual. And so we are told that it's 5.670 grams. And I'm going to put it over another per quarter, right? So this is the proper way to write our units here. And so what we end up getting should be how many quarters we have. In our case, that would give us 205,448. So you can see how nice it is to have this application of counting by mass because it's just saved us so much time. All right. And so thinking about the units here, I'm going to do that over to the side. What you have, if I just look at the units, is you're dividing grams by grams divided by quarters, right? And so you guys might have learned in your math class, and if not, I'll teach you now. But if you are dividing by fractions, you have to think about the top. This grams is just like if you were to write it as grams over 1, right? That doesn't change anything. So what you end up having then is dividing one fraction by another, and the rules for that is don't cry, flip and multiply. And so what that means is to both sides, you are going to flip and multiply by the one that you're dividing. So you end up having quarters over grams, multiplying on the top and the bottom. And so if you think about this, it's as if you are not gonna, you're multiplying by 1, right? And so what you end up having is if you look at each, like a top and bottom equation here, is that we know that this grams is going to cancel with this one, right? So I'll use purple here to show that these cancel. And then on the other hand, you have everything on the bottom cancels. This and this cancel each other. Quarters and quarters cancel each other. So we end up getting rid of the whole entire bottom portion here. Then if you look, the only thing that's left is quarters, all right? So I'm showing you how this works. You don't have to necessarily be pros at this yet, but showing you how we can get the right unit. All right, so let's talk about representative particles. We first have to figure out the right terms to use because as we know, we've talked about covalent molecules, ionic compounds, we've talked about atoms, and so these are all fancy names that fall under what's called an umbrella term. So particle. And what this means is particle is just very generic, all right? So I'm going to label my umbrella particle. So we can refer to all these things I just listed as a particle, but if we want to get more specific, the things that fall underneath it are atoms. You also have what's called formula units. And then lastly, you have molecules. And so the way I want you to think about an umbrella term is if I say, hey, let's say my umbrella term is fruit, the more specific things you could put under it are apples, bananas, kiwi, etc. So in our case, we're using the word particle, which I misspelled here. Give me 1 second. And so the specific terms we have for particles then are our atoms, formula units, and molecules. So it should be pretty easy to identify when you have an atom, right? It's just that smallest particle of an element. So if you see something like iron, carbon, bromine, those are easily identified as atoms. Now, molecules, that's actually not proper to use them for every single type of bonding that happens. This is specifically for our covalent bonds, all right? So how do we know if we have a molecule? Well, you just look for two nonmetals, right? So this is when we have nonmetals bonded to nonmetals. Those are going to be our molecules. And then our formula units, those are going to be our ionic compounds. So how do we identify those? Well, you'll see that you have a metal bonded to a nonmetal. So you guys should be pros at this by now. So biggest thing is all of these things we just talked about, these are all particles, except they have specific terms now. This is atoms, molecules, formula units. You do need to know how to do this. So let's practice, all right? So feel free right now to pause and work on this. And when you guys either get stuck or want to check your answers, then you can fast forward. All right, assuming you guys gave it a try by now then, let's go through this. So you'd find potassium, that's a metal. Chloride is a nonmetal, so that gets the term formula unit. Looking at HBr, both of those are nonmetals. So when you have a nonmetal, that gets molecule. Then you see magnesium. That is one single particle. We call those our atoms. So this is an atom. Moving over to the other side, we have again nonmetal bonding happening here. It's neutral, no charges are formed. We call it a molecule. Then we have calcium hydroxide, calcium being our metal, hydroxide being a nonmetal polyatomic. That's going to be a formula unit. And then lastly, diatomics are different, right? So you may be tempted to say atom, right? Because it's just a single element. But just the simple two here is saying, hey, we actually have two oxygens there. So we would throw this under our covalent bonding and therefore call it a molecule. So diatomics are molecules, not elements, all right? So making note of that here. Again, that diatomics are molecules. All right, so now that we have this idea of representative particles, we're going to kind of jump back into this weighing by mass. So we get to really get into using the periodic table and talk about that. And so moving on, we're going to introduce Avogadro's number, and it is very confusing. It is such a random number, but it actually has a purpose.